Still anyone else will be joining, or we can start the session? Okay, few hours joining. We'll wait for 2 more minutes. That's all. Then we'll start. Let them join if they want. Okay. Just we'll wait for 2 more minutes. Okay, let's start the session. 1 minute, I'll share my screen. So today we are going to discuss about something called as data structures. In that we have some concept which is related to UNC. So actually, whenever you want to organize a large amount of data in a well-defined form, or whenever you have collection of data in a large form, okay, whenever you are organizing a large set of data, or okay, whenever you want to organize a large set of data, then we preferably go for something called as data structures. So these data structures are basically categorized into two things. Okay. So these data structures are broadly categorized as two things. The first one is a linear data structure and the other one is a non-linear data structure. So whenever you want to group large set of data sets, or whenever you have collection of large set of data, then we preferably go for the type of algorithms preferably used are data structures. These data structures are broadly classified as linear and non-linear. So whenever you have collection of elements which are organized in continuous manner, I'm only talking about the arrangement. The data structures precisely, they are classified into, or they have been categorized as two types only depending on the type of arrangement you do on your data. So depending on the type of arrangement, your data structure is broadly categorized as linear and non-linear. So if your data is arranged, or if your data sets are organized in continuous memory locations or continuous fashions, then we call that as linear data structure. And if you store your data in a random fashion, then we call them as non-linear data structure. So the important thing under linear data structure, which we see are arrays, like you have stacks, you have queues, and you have linked list. Under nonlinear data structure, we preferably have the concepts related to trees, and the other one is graphs. Okay, so once again, I'm telling you, whenever you have collection of large data sets, okay, then we go for the implementation of data structure, that is organizing of a data into single unit, or single unit of organization is nothing but you call it as data structure. Depending on the type of arrangement and accessing of your elements, your data structure is broadly categorized as two things. One is linear data structure and the other one is non-linear data structure. So if your elements are stored or accessed, that is either you store the data or you retrieve the information. If it is happening in continuous manner or if it is happening in linear fashion, then it is called as linear data structure. And if your elements are stored randomly and they are accessed randomly, then it comes under the category of non-linear data structure. Under linear data structure, we implement the algorithms or we implement the data structures like arrays, stacks, queues, and linked list. These are basic things. And under nonlinear data structure, we have the implementations that are related to trees and graphs. So depending on the type of problem, depending on the type of your problem description or type of your problem statement, you can choose which data structure is used to implement that concept in your real world. Okay, so now today we'll talk about arrays. Okay, in C you only will be introduced with arrays. Anyhow, you have seen in your 2-1 semester you have a continuation of your data structures. So the first foremost definition of array is array falls under the category of linear data structure. Okay, array falls under the category of linear data structure. Arrays are nothing but collection of homogeneous elements. Okay, so first array falls under the category of linear data structure, and array is nothing but collection of homogeneous elements. Now arrays is collection of homogeneous elements. How does it store the elements? It stores elements in continuous memory locations. Okay, this is a very good definition, whatever it has been designed actually. If you observe, first, what is an array? Array is a linear data structure. What does an array contain? Array contains homogeneous elements. How your elements are stored? They are stored in continuous memory location. So when you combine these things, they say that array is a linear data structure, which is collection of homogeneous elements that stores elements in continuous memory locations under, very important line, under a single variable name. Okay, so if you group all these three statements together, that itself is your definition of an array. Okay, so once again, array is nothing but, first, what is an array? Array is linear data structure. What does array contains? Array contains homogeneous elements. How these elements are stored? They are stored in continuous memory locations with a referred by or under a single variable name. Now, what does this definition says and how does this definition look? We can observe. So first it is linear. So let's take, I have defined an array which is having linear. So I said I have a linear reference, that is memory locations. It contains collection of homogeneous. Homogeneous means they are of similar data type. Suppose if I say, if I'm storing a collection of student roll numbers. Okay, all the student roll numbers are unique and are of same data type. Okay, and suppose if I say I have designed my array to store collection of marks. Okay, now if you talk about marks, all it your data structure is collecting some student marks of same type. So whenever you are doing your problems, wherever you find something like this, like whenever they say something student marks, collection of student marks, or collection of student names, or their ages, or their uh, percentages, all this, whenever you see something, if you are preferably creating your data structure of this type, you should memorize, or you should memorize the best data structure to store homogeneous things is your arrays. This array can be implemented in different ways. Okay, so now it is collection of homo. So let's take, I'm collecting numbers or integers. Definitely I'll have integers. So I said it stores elements in continuous. So if I take the first memory location as 1000, so if it is an integer array, each memory block is occupied with 4 bytes of memory. So this next memory location will become 1004 and this will become 1008 and so on. If you observe, they are in continuous locations. Okay, one after the other. Now how they are grouped? They are grouped under a single variable name. So I have taken an array ARR of some size. Let's take 3. Okay, this is a user defined variable ARR array, and this 3 is talking about how many number of elements you are storing. I said 3, so I have taken 3 elements. So which type they are of same data type. So as these are collection of integers, I'll define my array as int. Okay, this is the definition, what they are designed, what they have designed actually depending on your collection of data. Okay, now your arrays can be represented only in two ways. We have only two things. One is one dimensional array. Your array can be represented only in two forms. We don't have many things. And the other one is multi-dimensional. So don't write 2D, 3D, all those. Okay, all these more than one dimension, automatically it falls under the category of multi-dimensional array by default. Now, where multi-dimension is categorized as 2D, 3D, and so on. You have now latest, you can represent almost, I guess, we are under 12 dimensions also, you can represent your array. Okay, your data set can be 12 dimensions also. Okay, but maximum we don't go beyond 4Ds. Okay, as a normal user, sophisticated users, they can define his own array of his type of his data set. That is only your data analytics what they do. So your arrays are broadly categorized as one dimensional and multi-dimensional. For time being, this is enough for you. So arrays are broadly categorized as one dimensional and the other one is multi. In multi, we have 2D arrays and 3D, and we have so many, but we concentrate on these things. Now, what is this one dimensional or multi-dimension is? In one dimension, your D is talking about dimension. So if your array is holding having only this representation, so this symbolically, the value which you are enclosing in between these two symbolically tells you that which type or which dimension is your array of. Suppose if your array is followed by only one dimensions or only one single representation of this, then it falls under the category of one dimension. If your array is followed by like this, it falls under the category of 2Ds. If your array is followed by 3, automatically it falls under the category of 3 dimension. Okay, depending on these representations, you can understand whether your array is one dimensional notation or two dimensional or it is three dimensional notation. Okay, now you can have two things. You can initialize your array during compile time, and you can also initialize the values for an array during runtime. If the values are passed, okay, if your values are passed or initialized before the compilation, then it becomes compile time initialization. If your inputs for your array are passed during the runtime, that is nothing but during your program execution, then we call it as a runtime initialization. Once again, if you are initializing the values before compilation of your program, that is indirectly you can say if you are designing something called as static values, then it falls under the category of compile time initialization. If you are changing your input dynamically for different types of inputs, then it falls under the category of runtime. So the first one, in one dimensional, you can initialize your array or you can pass the inputs to your array both by using compile time as well as runtime. Now, how the syntax appear for this? Data type followed by name of the, remember one thing, any programming language, the first foremost thing any student, I mean any person, whoever is doing programming, should be aware of syntax. If you know how to make use of your syntax, writing a program is very easy. Logical application is very, if you know the logic, you should know only the syntax rules. If you know the syntax, your program is giving you the best result. So data type, name of an array followed by size of array. Okay. Now similarly in runtime, so this is sorry, compile time equals to number of elements whatever you design. Okay. Now similarly you have your runtime array initialization syntax which takes, it looks some for more familiar similar to this, data type followed by name of array. And remember, as a good programmer, never pass variables in this name. Don't write nm so. Give some size. Later you can read it. Or you put it empty if your platform accepts. Okay, never ever pass your size of array with variable names. It's bad writing of program. Remember this. Never do that in any syntax rules. Never pass your memory allocation in terms of variables. Always it should be a numerical constant according to my choice. Okay. So now this is your basic syntax of one-dimensional array. That is, this is compile time initialization and this will be your runtime initialization. So once again, compile time is nothing but you will be initializing the elements to your array before compilation of your program and they are fixed. They cannot be changed during program execution. The values which cannot be changed during program execution comes under the category of compile time initialization. If the values can be changed during program execution will comes under the concept of runtime initialization. So you can design your initialization of your array using compile time or runtime. Okay, so you may have a question like this: what is an array? What are the categories of array? How many ways can we initialize array elements? Okay, you know what is an array? You will write the definition. Then how many categories your arrays are? There are two types. One is one dimensional array and the other one is multi. Under multi, you will talk about we have 2D, 3D and so on. How many ways can you initialize your array? Array can be initialized using two methods. Either it can be compile time or it can be runtime. Okay. So if they ask you to write the syntax for compile time for two multi-dimensional and 2D, then you will change the syntax. If it is asked for one dimensional, this is the syntax. 2D also I'll show you. So compile time you will write the definition as if the values cannot be changed during program execution, it comes under the category of compile time and they are static values. If the values that can be modified during program execution comes under the category of runtime initialization. And you have to write the syntax of this syntax of runtime and you will give one example like this. Simple example you give, that's all. You'll write example int a of 5 is equals to 1 comma 2 comma 3 comma 4 comma 5 and here you will write example as int a of 5 and you will show for loop you will take right to read your array elements I equals to 0, I less than 5, I plus plus, then you will scan only scanf percentile d comma address of a of I. That's all. Okay, understood with the introduction of arrays? Any doubt with this? Nothing, I guess. Anyone has any doubt with these two methods of writing writing basic what is an array, introduction to array? Okay, so we'll continue if not. So focus mostly in arrays on programs. According to my opinion, basic things we have only programs in arrays, not much concept. So now a simple thing, how to read and print elements of an array using runtime initialization and compile time. So one more thing, if anyone want any program to be taught to you in arrays, you can ask me now. I'll explain that program directly in your multi-dimensional or one-dimensional by the time we end this introduction of theory. Okay, because we don't have much in array theory concept. We have more programs only here. So in compile time, you'll write the example. You have to definitely write your example in precise way like this. Int a of 3, you will write it as 1 comma 2 comma 3. Then you will write, you will take one more variable I, and you can print for I is equals to 0. And we know that array index starts from 0, and we can even have negative indexes, but as programming things, we don't use negative indexes. We go for positive indices. Printf percentile d comma a of I. Okay, this is simple thing you will write. Matrix multiplication. Okay, I'll explain. No problem. Done. Still like this, if you have any doubts, let me know it by the end of this theory concept. Main, then int a of 3, take one variable I, then you'll write for, you know how to read your array elements and how to print. This is the basic thing which we do. Okay. Scanf, I just want to memorize you. That's why I'm showing. That's all. I know you people are good at this. Then for loop, I less than 3, I plus plus, then you are going to printf percentile d comma a of I. Okay, so here 1 2 3 values are always fixed. Whenever you run this program, this simple program, let's take it as 1.c. Whenever I run this program, always my array elements are only 1 and 2. That's the reason you're calling it as compile time. These values are fixed. But in this program, first I can give 10 to 5, then I can give 5 6 2. That is, if you are able to give a dynamic input to your initialization of the variable, then it can change. And one more thing I said, array is a collection of homogeneous elements which are stored in continuous memory locations under a single variable. Yes, all these elements are referred by only one single variable name, that is A. Okay, so this is about your one-dimensional theory. Hope everyone understood with this. Okay. Transpose matrix multiplication of two dimensionals. Okay, anything else you can ask. Fine, done. So now in one dimensional array, you have to learn linear search. Okay, maximum and minimum element of array. I don't know how many of you have these programs, but we have all. So for the people whom I taught, you already have these programs. I don't know how many of the other sections have the idea of these programs, but this is these things you have to definitely have to have an idea. Linear search, that is search an element in a given list of an array elements, finding the maximum and minimum element if in your, these are about one dimensional I'm talking. Then you have to have a minimum thing, that is sorting the list of array elements, like you have your bubble sort, you have selection sort, and the other one is insertion. So actually, quick and merge you don't have, but what do I do is I'll explain you the concept of implementing quick sort and merge sort. That is, they in 2 years back they gave that question to solve. That is, they didn't ask you the program, apply the technique of quick sort and merge sort. So I'll explain you that also. So linear search, finding the maximum and minimum element in the given list of array. Sorting may, in that you have bubble sort, selection sort, and other one is insertion sort. These things you have to definitely know. And reading and printing array elements, you know that anyhow. Okay, that's all here in one dimensional array. Okay, we'll talk about 2Ds, that is multi-dimensional. So in multi-dimensional array, we are focusing on two-dimensional arrays. Okay, so the name itself says every array initializations have two dimensions. The first dimension is talking about number of rows, and the second dimension is talking about number of columns. One second. Okay. So in the to be very frank, you get programs and theory equally actually. Programs will be definitely appears because it is programming subject like arrays, functions, recursion, structures, files. All these are programming oriented concepts itself. When you talk about in the first chapter, they'll give you both theory combined with your program. Like I said, you factorial, prime number, all these questions. So we can't say that this question is asked. Sometimes you get complete theory, okay, and they will ask you to write some examples under that theory, like give an example for implementing the concept of one dimensional. Then you can choose your own example and you can do it. Sometimes they'll ask you explain about linear search. So depending on the type of concept, you may get the question. So in first unit you have theory concepts, right? Like as I mentioned, structure, creating and running C programs, um, and types of languages, environments, all this. Okay, so actually we can't assume how paper for programming subject will be designed. Not only this, anything. Okay, depends. That's all. So you should be thorough with everything. Basically, be thorough with your lab programs. Beyond that, never I saw the paper. Okay, so let's continue. So you're talking about multi-dimensional. Under this, we have two-dimensional array. The name itself says the first dimension is talking about number of rows, and the second dimension is talking about number of columns. Okay. Now, even your two-dimensional array can be initialized or can be implemented in two ways. That is, either you can initialize your two-dimensional in compile time initialization, and you can have your runtime initialization. So how do you do that? The syntax rules is same. Data type followed by variable name followed by number of rows followed by number of columns equals to number of elements. Similarly, in runtime initialization, data type followed by variable name, then followed by number of rows followed by number of columns. Okay, so same thing in multi-dimensional, we are implementing two-dimensional array. Your two-dimensional array can be also initialized in two ways. Either you can initialize it in compile time mode and it can be initialized in runtime mode. So how your syntax takes? Always first thing is you're talking about data type followed by variable name, which has two parameters which this variable is going to accept. One is number of rows and the other one is number of columns, which is equals to number of elements. To be very frank, your two-dimensional arrays are very similar to the initialization of your two-dimensional arrays are very similar to your initialization of matrices. You people know, right? Whenever you initialize your matrix takes two things. One is number of rows and one is number of columns. Now, similarly, your two-dimensional arrays can be implemented in runtime mode. How does the syntax take? Data type followed by variable name, which is having number of rows and number of columns. So here the number of elements, whatever you are going to initialize, the values are always fixed. They cannot be changed during execution of the program. And whenever you are talking about runtime, you can give always a new input to the variable which you are going to declare and the values can be changed. Here you will write a simple example for compile time. And the other one is, what is this? Okay. Another one is runtime. So when you're talking about compile time, you write like this simple int a of sum 2 by 2, that is which is equals to, you can separate it like this 10, 20, 30, 40. Automatically this when you do this, you have two rows and two columns. 0 1 0 1. The first element, first the elements always fixed by rows by columns only. Okay, if 10 comes here, 20 comes here, 30 comes here, and 40 comes here. Okay, by default, however you write your elements, the elements are fetched and they are initialized depending on the followed by row by column fashion. First row, first column, first row, second column. Then only you will be entered into the next row, first column again. Okay. So now how do you do this? For I is equals to 0, I less than 2, I plus plus. I'm just showing you small example. I don't say always it is 2. It is your choice how much you want to define. You will take two things. The outer loop is always running for number of rows and inner loop always runs for number of columns. Then you will print, instead of one dimensional printing, you print here 2. Percentile is only 1. Even you have 2 dimensions, variable is only 1. That is the reason you are saying it is defined under a single variable name. Your dimensions may modify, but your variable is only always 1. That's the reason you'll use only one format specifier. So this percentile D, percentile C, we call them as format specifiers. Some say access specifiers. We have them called as control strings also. If someone asks you to write the control string for integer or character, don't get confused. What is control string? Control strings are nothing but these. Okay, percentile D, A of I by J. That's all. This is for your compile time. Now, similarly, if you talk about runtime, here you write int A of 2 by 2. That's all. And you will write for loop is same and here this is same. Here you will use one more line, that is scanf control string address of A of I by J. Okay. Then you are going to use your again for loop and you are going to printf. Okay. Then you are going to use your printf statement. So this is about your introduction to arrays. In this array, we have only this much as your theory. As I told you, you have to focus on programs. So we'll talk about the programs. So someone asked me some programs. Let me check them and I'll explain. Someone asked me what multiplication of matrices and one more transpose of a matrix. So still anyone has any program doubt? I'll just take 1 minute time. In that 1 minute, let me know which more questions you want in 2D arrays. Multiplication is one they asked. Okay, multiplication. Someone asked me transpose of a matrix. Still anyone has any questions in two-dimensional arrays? Let me know. I'll give you 1 minute time, please. Type it in the chat box. Hello. Siddharth, you asked me about reverse program, reverse of an array or what? Bubble sort and addition, and you want programs which we have to study. Okay, I'll give you which are basic things you have to prepare, but prepare everything which is available in the manual anyhow. Okay. Siddharth, can you answer my question? Reverse of an array you want, and bubble sort is one more. That's all. Okay. Okay, fine. We'll do with these four programs. Okay. Someone asked me bubble sort, and the other one is reverse of an array. Reverse of an array is very simple. Okay. Reverse of an array. Okay, we'll do this one dimension and we'll come back to multi-dimensional. Okay. So just give me 2 minutes time and just type the code and I'll paste and I'll explain just a couple of times. So first I'll explain what is bubble sort. Okay, with small example, then you will like understand the program logic. Okay. So let's take I have a list of array. Okay. So first, you know what I meant by sorting. Sorting is nothing but you're arranging your data either in an increasing order or decreasing order. That is, either you arrange your data in ascending order or descending order. So these sortings, actually, you have more things about sorting. You have external sortings and internal sorting. I'll explain you no problem again. So sorting is nothing but you call it as an arrangement of data, either an increasing order or decreasing order. That is, your arrangement of data can be in ascending order or it can be in the form of descending order. So this sorting can be implemented only with two things. Either your sorting can be internal method, that is you call internal sorting, or it is external sorting. So whenever you get some data set, in order to after you sort your data set, Okay, that is, it's your fashion. Either you want to arrange your elements in ascending or descending. If you are using any extra amount of space in order to store your sorted array, it comes under the category of external sorting. Again, I'm telling you, in order to store your sorted array, if we are using extra amount of memory or extra amount of space, that comes under the category of external sorting. And if you are not using any extra amount of memory in order to store your sorted list, then it comes under the category of internal sorting. Okay, once again, sorting is arrangement of data either in the form of increasing order, ascending order, or in the form of descending order. These sorting techniques are broadly categorized as internal and external sorting. What do you mean by external sorting? In order to store your sorted array, if you are using any extra space, it comes under the category of external sorting. And if you are not internal, means you are not using any extra space to store your sorted list, it comes under the category of internal. Under internal sorting, we have the implementations of bubble sort, selection sort, insertion sort, quick sort. The best example for external sorting is merge sort. So merge sort always use extra space in order to store its sorted result. Okay. So this is the introduction part of sorting. You understood what is external and internal, everyone? Yes. Now we'll under internal sorting, we are implementing the technique of bubble sort. Now, why these many at the end of the day, sorting will achieve the rule. What is that? You will have a list which is sorted according to your user choice. Either it is ascending or it is descending order. Okay, the arrangement is user choice. But which sorting is best? That is, which is taking less time and executing a feasible solutions. Okay, that is which is providing you a feasible solution in less amount of time, that is the best algorithm. So that's the reason they moved from one sorting technique to another sorting technique. Okay, only for time management, that's all. Now we will talk about under internal sorting, we are talking about bubble sort. So let's take a bubble sort first. So bubble sort, what does it do is, for example, if you are arranging your data in ascending order, so what does bubble sort do is, it will first compare every adjacent element. Okay, depending on your adjacent element, okay, you will be doing the implementation of swap technique. When do you go for swap? If you are arranging your data in ascending order, so if your adjacent element is less than the current element, okay, if your adjacent element is less than your current element, then only you do swap, otherwise you don't do anything. So in bubble sort, after every iteration or after every cycle of execution, what does we observe is the least element, if it is ascending order, the least element will be in its correct position. Okay, suppose I have a list 1, 8, -2, 5. Now, after my first cycle of iteration happened, okay, after my first cycle of iteration is completed, what do I observe is, whatever the element you have least, okay, I'm talking only about the first cycle. After the first cycle of implementation of your bubble sort, because you need to repeat this cycle for 4 different elements, right? After the first cycle of iteration is completed, we observe that the very least element in the list will be in its correct position. So what is the least element? -2. So -2 element will be fixed after the first cycle. That is, this element will be in a sorted position. So after every cycle, we observe this. So after every cycle, we observe that the element which should be in its correct position, it is occupying its correct place. Either it can be largest number if it is descending order, and if it is smallest number if it is ascending order. So always bubble sort, we will compare with adjacent elements. If your adjacent element is less, then you go for swap. If it is ascending order, if your adjacent element is greater, then we swap. If it is descending order, sorting technique. Now, how do we do this? Okay. Now, they'll give you like this. Let's take 3, 8, 2, minus 4, 56, then you have 1, and then we have 10. Suppose if this is your list given, and they may ask you to find the bubble sort and find number of swaps also. Sometimes they'll ask you how many number of swaps happen. So you should be able to count that at every cycle also. Now this is your list. Okay, now we will categorize this. Once again, can you able to hear my voice? Just I got it out. Can you people able to hear my voice? Yes, yes. Okay, thank you. So you will divide like this. Okay. Now this is 0, this is 1, 2, 3, 4, 5, and this is 6. Okay. So this, so first I'll ask, so I gave a maximum initialization for my array as 20. Okay, that is maximum of I can store up to 20 elements. Out of this 20, I can read my own size. I can take 2 elements, I can take 3, I can take 10, but maximum maximum I can store or a maximum input I can take are 20. And first thing, I am reading my size of array. Okay, n is talking about size of array. So in this example, I have taken 7, so I'll give 7. Now then the next foremost step is, first you should know what your input. So I have taken my input now. Okay. Now what do I do is, okay, a small change. Here I have not changed this line. Sorry. It is j is equals to I plus 1. Okay. Fine. Now what should I do is, if I start my current pointer here, let's take I have an index pointer I here. Now if I is at 0, I should compare the elements of 0 with the remaining adjacent elements 1, 2, 3, 4, and so on up to 7. If my index pointer of I is at location 1, again I'll start my comparison as 2, 3, 4, 5, and 6, so on. So if you observe, if I index is 1, your next pointer index is starting, let's take it as j, it is starting at location 2. If I is at 0, j have to be initialized with 1. So I'm considering here two things. Okay, I'm considering here two things. Okay. So here we need to consider two things. I'll take 1, 2. I'm taking only 5. Let's not waste time. What happened? Which internal sorting method is best? Insertion. Sorry, quick sort. Quick sort, quick sort. Sorry, someone asked me which insertions are. Because its time complexity is less. External में merge sort is best. Okay. So this is 0, 1, 2, 3, 4. Let's give 8, 3, minus 1, 4, and 2. Okay. Now this is your initialization and everything. So I said if your index pointer is at 0, the next index pointer should start from 1 to 3. If your index pointer is at 1, you have to start here. So that's the reason I have taken two indices. One is I is 0 and the other one is j, which if 0, j should start from 1. If I is 1, j should start from 2. So if you see, j is always something plus 1. That is, something is nothing but j is always initialized as I is equals to, sorry, j is equals to I plus 1. That's the reason I have taken my inner for loop as j is equals to I plus 1. Okay. So let's start now. So what I do is I'm taking one index pointer I here and the other index pointer j here. Now the basic thing is what I told. If you are arranging, let's take you're arranging your data in ascending order. Ascending order means smaller number to larger number, that is increasing order. Now what should I do is the value which is at the current location. Current location means your current pointer of I is at location 0. If the value at 0th position, if you will start tracing from your here. Now you start finding which element you will start finding which element is less than this current position. If it is less, if I find somewhere here less element, then I have to implement the technique called as swap. Okay, so you are going to trace. You are taking one fixed position, and you are start searching. Do I have any element which is less than the current element? If I have, then I have to go for the technique of swap. Now, if you observe, you're swapping. How do you do? Here at the end, you are only swapping two numbers. What is the technique you do for swapping of two numbers using temporary variable? Let's take I have a variable A, I have a variable B, and I have a temp. How do you write logic? Temp is equals to A. I write A is equals to B, and I'll write B is equals to temp. Right? This is the three-step. This is the logic which you will be applying for. Yes, you are applying it for what? Swapping of two numbers. Now, same logic we will be applying for your bubble sort also if you find that whatever the principle is. Now, first you can see here. Now, I value is pointing to location 0. Then you can see this loop. Is 0 less than n? Yes, it's true. Then you will enter into inner loop and j you are initializing as j is equals to I plus 1. So j value is at location 1. Now what should I do? I have to compare the element at index I should be compared with the element at index 1. That's the reason I'm writing here. I'm saying I will compare a of ith element with a of j. If I find if a of I is greater than a of j, then I will go for swapping of my number. What is a of I element I have? A of I means a of 0. What do we have? 8. Comma, a of j. A of j means the element which is at index 1. What do we have? 3. Now we are applying the logic between this. Is 8 greater than 3? Yes. As we are arranging the data in ascending order, I have to store my least element in my list first. So I have to apply swap. Now assume here we have a of I as 8 and a of j as 3. Now I should swap these two. Now what do I say is how you swap. So let's assume this is A, this is B. How do you write? T is equals to A. So wherever you have A, you are assuming it as A of I. So temp is equals to A of I. A of B, A is equals to B. That is A of I is equals to A of J. Then finally B is equals to temp. That is nothing but B of A of J is equals to temp. Okay, this is the logic. So what happens now? As you have find the least 8 is greater than 3. As the condition is true, what should I do? I will swap these two things now. So what do I get here now? It is no more 8. This is no more 3. Okay. So my new list will be, this is 3 and this became 8 now. Okay. So now what happens? Now after this phase is completed, now you will increment j. First your inner loop has to complete, then all. Your I is still here, but your j is incremented to which location? Here. Ma'am, after one iteration, we will get the highest number. No, one iteration means I'm saying one complete cycle. Your iteration is not completed, not highest number. Ascending order, the least element will be in its correct position. You can observe. I'll complete this cycle. Now j is here. Again compare a of I with a of j. What is a of I element now? 3 is compared with whom now? -1. Okay. So you can count in the first cycle for how many swaps also they may ask, you can count. Now 3 is greater than -1. So if the condition is true, what will I do? Again, I am going to implement the swap technique. So what happens? My new element will be, I don't have 3 here. So I'll get -1 and 3 here. Now this is done. Now again, what will I do? J is incremented, right? Your J value is J plus plus. Now J comes here. Okay. Now what happened? Again, you are doing A of I with A of J. What is A of I element now? -1. What is A of J? 4. Is -1 greater than 4? Condition is false. So I don't do anything again. I'll simply just move my forward pointer. That is, I'll only do J plus plus. J comes here. Now what is the next comparison we are having here? Shit. So what we have the next comparison? So I had, sorry. I had -1, 3, 8, 4, I think, and 2. Okay, let's check. So now your I is here and you have your J here, right? Now we are comparing -1 with 2. So is -1 greater than 2? Again, condition is false. So what will I do? I should increment J. Now when J becomes 5, your N value is also 5. 5 less than 5 condition is false. Now your first cycle is completed. Now if you observe, after your first phase of your cycle is completed, the least element has been already sorted in the list. Yes. Yes or no? Yes. Understood everyone? Shall I go for the second iteration? If you want second cycle, I'll show you, no problem. So now, okay. If you understood, I'm happy. But okay. Now again, now your inner loop fails, so you'll increment I. Now I is at 2. J should start from 3. Sorry, I is at 1, right? I plus plus. I is at 1. So J starts from 2. So you will, 1 second. So now I here, J is here. Now compare. Again, is 3 greater than 8? No swap. So what will I do? I will only move J pointer. Is 3 greater than 4? No. So don't do anything. So J is incremented. Is 3 greater than 2? Yes. So what will I do? I will swap. Now what happens here now? I will have 2 here and I get 3 here. Now when J becomes 5, again 5 less than 5 condition is false. Now by the end of your second phase of cycle, if you observe, the second least element is in its correct position. Understood everyone with bubble sort? Anyone has any more doubts? Can I go for the next program? Okay. So the next one we'll see. It's very simple. Someone asked, okay, this is your bubble sort. You want me to execute this program and show? Anyone want me to execute this program and show bubble sort? Not needed. Okay, no, so you not needed, I assume. So someone asked for reverse of an array. So let me change this. It's very simple actually. This is your original array. Okay, printf. Just go here. Okay. So this is simple thing array. Okay, simple example. So you have your original array. Let's take you have 5 elements or 4. Okay, let's take 5. So you will write 0, 1, 2, 3, 4. Okay. So n is number of elements. 5 I will give. So from 0 I'm reading my elements. So let's take 10, 3, 4, minus 2 and 8. This is my list. Okay. Or if I print original array, I should get my list like this. You start from 0 until you reach less than n. That is nothing but it is 4. Okay, when n becomes 5, your loop have to stop. So what do you get here when I do this line? I get the same elements. I get 10, 3, 4, minus 2, 8. Now what is your reverse array? Reverse means you have to start from this location. Now what is your original value of n? It is 5. But you are storing n minus 1 elements in your list because you are starting your index from 0. You are storing your elements in you are storing n minus 1 elements in your list. So I write I is equals to n minus 1 should be my start element. So n minus 1 means what? I can't write n because in fifth location we don't have any element. So because if you are reading your index from 1, it's correct. 1 I is equals to n because you read the elements from 1 to 5, but your index is starting from 0. Definitely you can't take it as n. It should be n minus 1 because you have done n minus 1 insertion of your elements. So this is not done. Okay, you don't do that. Okay. So what do? I is equals to n minus 1 means I'm starting my index pointer from n minus 1 till what? Until I reach my base index which is greater than or equal to 0. Here you are moving from 4, 3 to 1. You are moving from larger number to smaller number. Then I write you are decrementing. So I minus minus. Now when I is equals to n minus 1 is your first initialization. N minus 1 means I value becomes how much? 4. Is 4 greater than 0? Yes. You will print A of 5. What is the element in the fourth position? 8. So first 8 is printed. Then I go for the re-evaluation. What I'm doing? I minus minus. I previously was 4. Now I value becomes 3. Again test check. Is 3 greater than 0? Yes. What do we have the element in 3? Minus 2. Again re-evaluation. I minus minus. 3 becomes 2. Is 2 greater than 0? Yes. What do we have the element in 2? 4. Again I minus minus 1. Is 1 greater than 0? Yes. What do we have in element in 1? It is 3. Now 1 becomes 0. Is 0 greater than equal to 0? Yes, 0 is equal to 0. What do we have at 0? 10. Again I minus 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 1. Condition check. Is minus 1 greater than 0? Condition is false. The loop stops. Understood, Siddharth? Okay. So, okay. Take 5 minutes break. Okay, only 5 minutes break. We will continue with matrix multiplication, transpose, and character strings. Okay, we'll complete this by 12 o'clock. So 5 minutes break. Sharp 11 o'clock. I'll pause my. I will continue my session. I'll pause for 5 minutes. Take 5 minutes break, and you again come back. Okay. By this 5 minutes, if you have still any more doubts or still any more concepts to be discussed, you can ask me. You would think. Okay, take 5 minutes break. Insertion in one dimensional array you want? Okay, I'll explain you. No problem. I will send you the important questions or I mean important programs. You prepare them. Okay. MCQs only. Mid for mid you have MCQs. 25 MCQs randomly you'll get. Okay. Bubble sort insertion selection. Okay. Fine. Just give me 2 minutes time. I will type the program and explain you that transpose and matrix multiplication. Okay. Okay. So now we are talking about transpose of a matrix. So you people are familiar with transpose of a matrix. So your number of rows and number of columns are interchanged. Your rows becomes columns and column value have to become row. So here it is a multi-dimensional. Under multi-dimensional, it is a two-dimensional array. So if you see this first one, A of 20 by 20, you understand here you are defining two dimensions. The first dimension is always talking about number of rows and the second dimension is always talking about number of columns. So in order to read rows and columns, R is a variable which I'm using for number of rows and C is a variable which is I'm talking about columns. So out of 20, it's my choice. Number of rows are how many and number of out of 20, another dimension 20, I will choose number of columns. So I'm taking a 3 by 2 matrix. That is nothing but 3 rows followed by 2 columns. So first I'll read my matrix element. So when I is equals to 0, okay, when I is at 0, you will run your J loop for number of columns. That is 2 columns. When I is at 1, you are running J for again 2 columns. Again, when I is at 2, you are running J for another 2 columns. So this is your math. See, I don't say that internally your processor will take a box like this and it will divide it in and it will store. It is only our perception. We think your elements will be stored like this, and according to that, we are fetching. Okay, I don't say that your elements is represented inside your memory in this fashion itself. They are only stored according to 0 by 0 position, 1 by 1 position, that's all. It is our assumption how we are taking your representation. Now you got your array. Now what is transport? Your rows have to be exchanged with columns. So first you have to think about your loops. The outer loop is running for rows and the inner loop is running for columns actually. Now, what should happen when you exchange this? Okay, when you turn this, what happens now? Now your rows are inverted to 3 rows and your columns has to be, excuse me, your rows will be exchanged to 2 rows and your columns has exchanged to 3, right? That means your outer loop should run for 2 rows and your inner loop should run for 3 columns. That is the reason I have written here your I will start from 0, I less than columns. Okay, always you are exchanging your rows with columns. Definitely you have to exchange your loop also. See, if it is 3 by 3, this even you write row R and C, there is no problem. But if you are having an unequal dimension, that is rows and columns are different values, definitely your outer loop should run for number of columns and inner loop is running for number of rows. That's the reason I'm writing it as J as AR. Okay. Then how do you print? You are printing which elements? Row by column elements. So you will write A of J by I. Okay. I have here one bug. We will see what is that. Okay. We will, once I want to show you that. Okay. Now you see here. So as I mentioned, you have first one, 3 rows and 2 columns. That is 6 elements. It will 3 rows and 2 columns. 0, 1, 0, 1, 2. So what are your 3 rows and 3 columns here? 1, 2, 3, 4, 5, 6. Okay. So if you observe here, what should be your expected outputs? Your rows should become columns and columns should become rows. So you're writing your outer loop running for I is equals to 0, I less than number of columns and I plus plus. Then you're running your j for j is equals to 0. J is running for j less than r, j plus plus. Don't write a of I by j. You need to interchange your a of I by j. Now it have to become a of j by I. That is, you are printing a column by row fashion. Okay, so you are exchanging, your number of rows are exchanged with number of columns. So a of I by j will be printed as a of j by I. Now what happens here when I is at 0? What is your row actually? Row value is 3 and column value is 2. Your loop I less than 2. Condition is true. 0 is less than 2. So what do you write here? J is 0. Now j is also initialized. Yes, 0 is less than 3. So what should I do? I am printing a of j by I. Okay, that is a of 0 by 0. What is that element you have? 1 is printed. Now j is incremented, right? Now j becomes 1. 1 is less than 3. Again a of j by a. A of j by I. Okay, what is a of j by I? You can't write here I by j. You have to exchange. Transpose is that's what. You are exchanging row with column. Row value is I, column value is j. Now transpose if you do, you will write a of j by I. Now the next element is a of 1 by 0. What do we have in element as 1 by 0? 3. So 3 is printed. Now when j becomes 2, you are printing a of 2 by 0. What do we have element in 2 by 0? 5. So 5 is printed. So when j becomes 3, loop fails. Right? So now again, you have I is incremented to 1. J again starts from 0. Right? J again starts from 0. You are printing what? I 1 by 0. 1 by 0. What do we have the element at 1 by 0? What do we have? 1 by 0. Is it correct I'm doing? Ah, yes. What is I? I is 1. Right? What is J? J is 0. What do we have element at 0 by 1? Not J 1 by 0. Sorry, 0 by 1. What do we have? 0 by 1? 0 by 1. So you got 2. Now J is incremented to 1. What do we have in 1 by 1? 4. J is incremented to 2. What do we have in 2 by 1? 6. 6 is printed. Now when J becomes 3, loop fails. When again I is incremented, I becomes 2. 2 less than 2 condition is again false. So you will get the transpose of matrix. Understood? Someone asked me about transpose of matrix. Clear? Still doubt anyone? Transpose of matrix. Understood everyone? So you have to change your outer loop, inner loop and your print statement. So your outer loop is running for number of columns and inner loop is running for number of rows, and you should print column by row. Because we are reading elements in row by column, you will print it in column by row fashion. Okay, done. So we'll talk about matrix multiplication. Just 1 minute. I'll just write the code. Just give me 2 minutes.
matrix and columns. So C of I by J is nothing but rows and columns. So we need three matrices, no? So B of 20 by 20, and we are finding C. Resultant is C of 20 by 20. So for rows and M, this is all we have to change. N comma M by N, then P comma Q. If I take P comma Q, I need two things now. Okay, you will write B also. A I less than N by N by N, P by Q. So 2 by 3, 3 by 2, so N by N, P by Q, N by Q is your resultant matrix. No? Okay, so this is only for N times. This is one for Q times. This is running for N of P times. Okay, C of I by J is equals to C of I by J plus P of I by K into B of K by J. Okay, so this is the formula. Here I'll write C of I by J is equals to C. So this will be one loop, another loop, another loop. So I is running for m rows and J is running for 2 columns, and C of I by J equals to 0. So that's all. Okay, done. Okay.
First thing you have to understand is in matrix multiplication. So let's take I have a matrix A of 3 by 2, that is 3 rows followed by 2 columns, and B is also 3 by 2. Okay, ma'am, we are not reading B1. Yeah. I didn't write because I will tell you that. Yes, we have to read everything. Okay, so we are having two things here. Okay, one is you are reading the elements into A matrix and B matrix. So whenever you apply matrix multiplication, it is very similar to your max rule. What do? If the first column, okay, you know that if the number of columns in the first matrix, if it is not equals to number of rows in the second matrix, you will simply print a statement as matrix multiplication is not possible. Okay, so like now this is your rows in the first matrix, this is your columns, and this is row and this is column. You can write here simple condition if, and so for this I'm taking a variable as m, this is n, this is p, this is q. So if the columns of first matrix, what is the column element of first matrix? N. If it is not equals to the number of rows in the second matrix, what is the number of rows variable in the second matrix? B. As if this condition is not satisfied, you simply say matrix multiplication is not possible. Yes or no? We know that if the columns of first matrix, if it is not equals to rows of the second matrix multiplication is not at all possible. So if this is my example given, if I read the elements, if I give A as 3 by 2 and B as 3 by 2, I will compare the number of columns of first matrix with the number of rows in second matrix. So I'll simply throw a mistake as matrix multiplication is not possible. Assume that this condition is false. So this is the first raising condition we have to check in your matrix multiplication. Okay, I didn't write, but when executing the program, I'll show you how to write. Now the next foremost condition is, suppose you think I gave a matrix A as 3 by 2 and matrix B as 2 by 3. This is possible because the number of columns of first matrix is equals to number of rows in the second matrix, and your resultant will be what? When I do A by B, it will become 3 by 3 matrix. These two gets cancelled, right? This gets cancelled, and you get A by B matrix as 3 by 3. This is your concept. So first, what is the necessary thing? I have to read number of rows and columns of first matrix. Okay, I didn't change them while doing program eld. And then I have to read the number of rows and columns of second matrix. First I said, right, if comparison you do, if it is false, right, if it is true, that is if row is not, if columns is not equals to row, you simply throw an error like matrix multiplication not possible. Otherwise, start reading the elements of matrix A as well as you will read the elements of matrix B. Same thing you will do. Instead of I less than M, here you will take less than N, and here it will be J less than, P and Q. Okay, now so A is 3 by 2 and B I have taken as 2 by 3. So I am referring this as M by N matrix, and this I'm taking it as P by Q. Finally, your resultant of A by B should be what? It should be M by Q. Okay, so now you assume here in matrix multiplication, what we do is our first concept. What we do always, for example, I have this example like 3 rows and 2 columns, and the other one is 2 rows and 3 columns. 3 rows, so 0, 1, 2, 3, 4, 5, right? The other one is 2 rows, so 0, 1, 2, 4, 5, 6. This is B matrix and this is A matrix. And here you have I by J elements, and this will be I by J elements. Okay, now we know that when you are doing matrix multiplication, the first row elements should be multiplied and added with first column. Again, the first row elements should be multiplied with this. Again, this have to be multiplied with this. In order to have, first you multiply, then you have to add to the previous result, right? So in order to apply this, what is happening is, if you observe here, the first row elements should be multiplied with the column of the second matrix. Am I right? So you know this, your first row elements should be multiplied with the column. Now what indirectly is happening is, if you observe this, whatever the column you have for the first matrix, that is reflected as a rows for the second matrix. Yes, so what do I do is, to read my outer rows, okay, I will use a variable called as I. Okay, now the common variable I will take, which for matrix A will act as a column, and that variable act as a row for this second matrix. So that I will take it as K. And the outer loop, that is nothing but your column, I'll take with a variable as K. Now what indirectly we are doing is, whatever the element you have at I, you are multiplying with column, and you are doing K times of J indirectly. Now what is this K? K is acting as a column for A matrix. For the second case, K is acting as a row for the B matrix. That's the reason in matrix multiplication we use 3 loops here. Okay. First, why we use 3 loops is this. What is this third loop is talking about? This is talking about your row. This loop for the first matrix act as a column. Now this is acting as a column. This loop for the second matrix act as a row. So that is the reason we are taking a common variable K, which is acting as, I'm explaining. Okay, fine. Observe here. You see this dimension, you will understand. Now these two are common. So to run number of rows for the first matrix, I'm taking it as A. To run number of columns, I'm taking the matrix variable as J. Okay, I'm taking the variable as J. Now, as if you observe, both A and B has common values. Data is nothing but what do I do is I will take a common variable K, where K is acting as a column for matrix A and K will act as a row for matrix B. Okay, so K loop will be running for number of columns for matrix A and K will be running for number of columns for matrix, number of rows for matrix B. So when you do matrix multiplication, we are taking here 3 loops now. Okay. So as I told, we will do this. 0, 1, 2. This is 0, 1. 1, 2, 3, 4, 5, 6. Why? Because also I'll tell you. Next, what I told, 2 rows and 3 columns. 1, 2, 3, 4, 5, 6, 0, 1, 2, 0, 1. Why? Because if you observe, A is 3 by 2, B is 2 by 3. Now, why I'm taking a common variable is, at the end, this 2 gets cancelled, right? Your resultant is A of I by J only. That's the reason I'm writing here C of I by J only. I'm not using K. K is already taken as an intermediate variable in order to act as column for A matrix, and K is acting as an intermediate variable to act as a row for matrix B. That's all. Okay, why we have to go for this logic is because you're not applying the matrix multiplication between two adjacent elements. Your row should be multiplied with column. For that reason only we are applying this technique of K. Okay, so now you observe here how this happens. So you are finding a resultant matrix C. Okay, what does C of I by J contains? This is 3 by 2 and that is 2 by 3. So your resultant matrix is 3 by 3 matrix. 0, 1, 2, 0, 1, 2. This is your output matrix, right? Now we will fill. Now first what do I do is I'm taking the first element I as 0. And I'm taking one more variable J as 0. I is running for how many number of times? Number of I always is running for rows and J is always running for columns only. Okay. I is running for rows of matrix A and J will be running for columns of matrix B. And K is acting as column for I and J row. Okay. Understand this please. You have A 2 dimensions, B 2 dimensions. For A, for running my number of rows, I'm using a variable as I. Okay. Now, similarly for A, I am taking K as my column variable. Similarly for B, K is row and column will be J. Now we are doing the product between these two. That is, you write A of I by K will be multiplied with B of K by J element. And this have to be done with sum initially, right? Right? For after every multiplication you do the addition also, right? So I'm writing sum plus A of I by K plus B. This sum is nothing but I'm taking the variable as C of I by J. Okay, you'll understand when I execute in sequence of steps more precisely. But you should understand why I have taken K. What is K? K is a common variable acting for both A matrix, and this is A matrix and this is B matrix. Now let's start. This I is running for rows, J is running for columns. K will act one time as column element and K act as row one time as K act as row one time. Now I is 0. J is also 0. Now what I'm saying? Multiply then add. So initially that sum I'm taking preserving it as C of I by J value as 0. So what do I have? C of 0 by 0. Initially I have preserved a value as 0. Okay, we don't know what. Now K is also initialized to 0. Now you observe right to left evaluation. I have a formula. you have a formula what? A of I by k should be multiplied with B of k by j. This is the formula. Okay. Same, A of 3 by 2 multiplied with B of 3 by 2. Now, A of I by k. That is nothing but, you see this thing, 0 by 0. What do we have in 0 by 0? 1. 1 is multiplied with B of k by j. What do we have in B of k by j? B of 0 by 0, 1. When we do 1 into 1, what do we get? 1 plus C of I by j. C of 0 by 0, initially I have taken a value as 0. So 0 plus 1 becomes how much now? 1. So I will have here now 1. This is done. Now again increment k, because you have one more element right now. You have 0 by 0 is multiplied with 0 by 0. Now you have to repeat this. Now k is 0. Now k becomes how much? 1. Same formula we will see. Okay. A of I by k. Now, okay, you will get confused. I'll not write this. I'll write in the bracket only. Now this becomes 1. Okay, you are in a loop should fail. Now what do we have? A of I by k means you are multiplying A of 0 by 1 should be multiplied with B of 1 by 0. Right? A of this 0 by 1 should be multiplied with what now? 1 by 0. This is the thing you do, right? Now you should understand why I am using this third variable k. Right? What is 0 by 1 element? You have 2. It is multiplied with wait a second, A of I by k, correct, is multiplied with B of k by j. What do we have in B of 1 by 1? 4. What do you get? 8. Now what I do after I multiply, I should add it to whom now? C of I by j. What do we have in C of I by j already? 1. So 1 plus 8 becomes how much? 9. So this value is becoming 9 now. Right? Understood? Now you see. This is completed. This part. Now you should understand why I am using k. Okay, which is acting how that functionality happens. Now what I'll do, k plus plus again. K become 2. But 2 less than, this is not n. What is n? M by n. 2 less than 1. Condition is false. Okay, I should write that also, right? M is, n is 3 rows, 2 columns. 2 rows, 3 columns. So n is 2. So 2 less than 2 condition is false. So now your first iteration is done. So this loop is failed. So what will I do now? This is eraser. Okay. Now what we'll do? Now come and increment j plus plus. J becomes 1 now. Okay, j was previously 0. Now j value became 1. Again, I'm finding the next element at C of 0 by 1. So C of 0 by 1, I'm initializing it with 0 first. Now again, k starts from which location? 0. Now same formula. A of I by k should be multiplied with B of k by j. Now which row? First row, 0th element should be multiplied with whom now? Someone is asking something. Ma'am, can you please? So next what you have to multiply? 0th row with first column. This one, right? Yes or no? 3 comma 4 now should be multiplied with 2 comma 5. Right? Now we see how it happens. A of I by k. I is what? 0. You are multiplying 0 by k is 0 by 0 element should be multiplied with 0 by 1. Are we doing correct? Still we are in 0th location only, right? Right, because you are finding now 0 by 1 element. This element you need to find, right? K can be, yes, you are correct. K can be less than n or it can be less than p. No, no, no. K cannot be less than m because m is running for rows and q is running for columns. So either you can run k for n or you can also run k for p because n and p values are same. When they are same only, you are doing matrix multiplication. Okay? Fine. Now 0 by 0. What do we have 0 by 0 element now? 1. Okay. 1. Okay, now we didn't complete this row, right? Sorry. 0 by 1. What do we have in 0 by 1? 2. When you multiply 1 with 2, what I get? 2. 2 should be added to previous sum. What do we have? 0. So what happens now? 0 plus 2. Now this value became what now? It became 2. This is one cycle is completed. Now again, k was 0. Now k is incremented to 1. Now k is incremented to 1. Again, what is the formula? A of I by k should be multiplied with b of k by j, and that have to be added to c of I by j. A of I by k. What is A of I by k now? 0 by 1. That is 0 by 1 element you are multiplying with 1 by 1. Correct. What do you have in 0 by 1? 0 by 1 is 2. 2 should be multiplied with 1 by 1. What is that 1 by 1 element you have? 4. Correct? Yes. 1. This is 1 by, sorry, 1 by 1. 5. So 2 multiplied with 5, you get what? 10. So 10 plus previous sum. What do we have? 2. So it becomes what? 12. Now you observe this relation. At the end, after you do matrix multiplication, which element are we finding? 1 and 1 gets cancelled. You are finding the element at location 0 by 1. Yes, I found 0 by 1. Next again, what you will do? You have to find a new element which is at location 0 by 2. Okay, now you are again done. This is also done. Now you are again finding the element which is at location 0 by 2. Right? You are finding this value now. This is question mark. Now what happens? J previously it was 1. Now J value becomes 2. And K again starts from 0. So at the end of the day, you are finding C of I by J. That is 0 of 0 by 2. So what I'm doing the relation, I'm multiplying 0 by 0 should be multiplied with, 0 by 0 will be multiplied with 0 by 1. Again 0 by 1 should be multiplied with 1 by 0. Okay, in this way you are applying the relation between them. So now you see how this happens. So 0 by 2, 2k starts from 0. Now first you are taking a of I by k. That is 0 by 0 is multiplied with 0 by 2. What do we have in 0 by 0? It is 1. Now you are going for this row. Okay. 0 by 0 is 1 into. What do we have in 0 by 2? 3. You get what? 3. Should be added to previous sum. That is nothing but 0. This was 0. So now it is updated to 3. This is completed. Now again, j is incremented to 1. Now what you will do again? 0 by 1 is multiplied with 1 by 2. What do we have in 0 by 1? It is 2. What do we have in 1 by 2? Where is 1 by 2? 1 by 2. This 6. It is 12. So what is previous sum in C of I by j? We have 3, right? 3 plus 12. We do the same way, right? Multiply then add. 12 plus 3 becomes 15. So this value became 15. Now the loop stops. Okay, if you see, every time you are finding for 0 by 0 you are doing what you will do? 0 by 0, 0 by 0. So you get 0 by 0. When you are finding 0 by 2, we are doing 0 by 2, 2 by 0. Okay, 0 by 2 you should find. Then you will have 0 by 1, 1 by 2. So then I'll get 0 by 12. So this k is acting as intermediate between rows and columns. Anyone has any doubt? Anyone want me to repeat this example? You all understood this program. Why? First of all, understand why we use k. Okay, why are we using this k variable and how k is acting? K is acting as, if you see this formula, k is acting as column for A matrix, k is acting as row for matrix. So what is happening at the end is, if I have A of I by k, B of k by j, definitely your resultant is A of I by j. Why? Because this is 2, this is 3, this is 3, this is 2. This 2 gets cancelled and you get 2 by 2 matrix only. Understood matrix multiplication? Someone asked me. Anyone didn't understood, please let me know. Take 1 minute time. Someone want me to execute on show? So now if you observe here, I give a number of rows and number of columns like let's give 2 by 3 and 2 by 3. I get, okay, 23 it is taking. Sorry. What happened? Ma'am, we need recording class for people. So you can give here 2 rows, 3 columns, and again 2 rows, 3 columns. So it's not possible because the number of columns of first matrix is not equal to number of rows. So it will end. So, so you can give now 2 rows, 3 columns, 3 rows, 2 columns. Okay, now it will take 2 by 3 means how many elements? 6 elements.
So I'll give first matrix elements 1, 2, 2 rows, 3 columns, 3, 4, 5, 6. And second row matrix 1, 2, 3, 4. Okay, this is 3 rows, 2 columns, no? Okay, 4, 5, 6.
So you get 2 by 2 matrix, right? Hope the answer is correct. Okay, understood everyone? So this is your matrix multiplication. Fine. Anyone has any more doubts in matrix multiplication? Okay. So someone asked me insertion of elements into one dimensional array, right? Can you send the speaks of these programs? Okay, I need to save them.
Okay, I'll send it.
Ma'am, can you explain the difference between bubble sort, insertion sort, and selection sort? Difference means you want programs.
Method.
Okay, I'll explain. So let me complete inserting an element into array, then I'll explain the difference between all those sorting. Okay. Just give me 2 minutes, 5 minutes, 2 minutes time. I'll complete writing the program, then explain you. To insert a new element into array, you can do it in different ways. Okay, that is your choice how you want to do. I'm showing you one method. First, what should we know is when you're inserting a new element or you're adding a new data into your existing data set, first your memory have to be created for that. Okay, then you have to go for your insertion option. So when you're doing this, there are two things you have to remember. One thing is first you have to have a memory, then only you are able to insert that. Okay, that is your as assigning memory. Then you have, see in your class you have already 60. If I want to insert another new person in your class, definitely I need some place for him. Okay, for example, he have to be insert in between somewhere 20 and 30. Definitely I have to move the elements, then I have to insert. I can't make that person to sit on that. What happens? I will lose the original data. Now what happens is here, for example, I have the list like this: 10, 20 and 30. So first foremost point, I want to, this is 0, 1, 2. I should know where I want to insert. I can insert at location 0, I can insert in between 0 and 1, or in between 1 and 2, or at the end of the 2. It's your choice. End anywhere or at the last. These are the positions where you can insert your data into your array now. So first foremost thing is you need one space. Then depending on that, you have to move that elements. Okay. Now, for example, I told my position of insertion is at location 2. So what should I do? First, I can directly write A of position is equals to the new element. I can't do this. What happens? This 30 will be replaced with that element. I should not do that. I have to have my data. I should not disturb, I should not lose my original contents, but insertion of new data should happen in the list. So what I'll do is, now first, I have an array now, 5 elements, 0, 1, 2, 3, 4. I said n is equals to 5. This is your choice. I have 3, 48, 26, 11, 10. So first thing is I should read two things from the user. One is which position he want to insert. The second thing is what is his new element he want to insert. Let's take I want to insert at position 2. My new element is 100. This is my operation. So what do I do is first, previously it is 5. Now your as you're adding extra element, my memory locations will become 6. 0, 1, 2, 3, 4, 5. 0 to 5 means it is 6 now. So now first I will read my elements into my array. Then I'm finding my position of the insertion. Then I'm talking about what element I want to insert into the list. I can't insert if my position is greater than n. Your n is 5. If I say position as 7, it is wrong. You can't have your position greater than your number of elements in your list. So what I'll do, I'll simply say insertion not possible. So I'll go into else. The condition is true. 2 is greater than 5, condition is false. You enter. Now what will I do is, I have to insert at location 2. Before I insert, I have to move these elements. Right? For that, I'm writing this loop. First, I will move the elements until I reach my position. I don't need to move this 48 and 3. I should only move the elements from which location? From position till n. So I write when I is equals to n. What is I value now? I value became 5. Is 5 greater than position? Yes. So I'm saying what? The previous element of 5, that is the element which is at 4, I'm moving it to 5. Okay. Understood what I'm saying? I am moving the elements in right from the fourth location. I'm shifting to fifth, third to 4, 2 to 3 until I reach 2. So I'll write A of I is equals to A of I minus 1. What do we have in A of I minus 5? I minus means it is nothing but 4. What do we have in 4? 10. That 10 is assigned to location 5. Then I minus minus. Now I value becomes 4. Is 4 greater than 2? Again correct. Now what we are doing? I minus 1. A of 3 is moved to which location? A of 4. What do we have in A of 3? It is 11. Now I value becomes 3. Okay. Now is 3 greater than 2? Condition is true. Now A of 2, I am moving to A of 3. What do you have in A of 2? 26. 26 is moved. Now when I becomes 2, 2 greater than to position, it means you have reached to the desired position. So what will I write? I simply write A of position equals to the new element. What is that? 100. So I have 100. The remaining elements are as usual. They no need to shift them. They will be in the same location. Understood, everyone? Anyone did not understood, please let me know. Got it? Insertion of a new element into the list. So now you will print the elements from 0 less than equals to n. That is this. Understood or not? Inserting a new element into the existing array. You can write this program in different way also. You can write it in another logic also. I'll show you that. So you can start shifting from position only. Okay, you know the position. I will shift until some condition. Like you can write for I will begin I from position I greater than, sorry, I is until less than, okay, position means to n I plus plus. Instead of this, I'll write a of I plus 1 equal to a of I. This is also works. This also can be done. What I'm doing, a of phi is equals to position. Position means what? For example, I give position value as 2. Okay, I'm moving 2 to 3, 3 to 4, 4 to 5. Okay, is 2 less than equal to n? Yes. So a of I plus 1 equal to a of I. So I'll write a of 3 is equal to a of 2. Okay, so what do I get my new array? Let me draw it. Zero, 1, 2, 3, 4, 6 elements, no? So I'm saying a of 3 is equals to a of 2. So I'll get here 26. Then I plus plus I was 2. Now I becomes 3. Then again this formula a of 4 I'm writing with a of 3. A of 4 with a of 3. Then I becomes 4. Then I'll write a of 5 is equals to a of 4. A of 4, 5 equals to, okay, not need of less than n, right? So then I'll get 10. When I becomes 5, 5 less than 5 condition is false. Now finally you have preserved. Then again a of position equal to element. So a of position value is how much? Position value is 2. So I'll get here 100. Right? That's what, no? Either you can do it as less, see, same thing. No, 1 second. Yeah, I understood you. So I'll show you. So I'll give size of array as 5. 1, 5, 8, 9, 6. Enter position 3. Let's give an element as 123. So 0, 1, 2, 3. You got it, no? 9, 6, 1, 5, 8, 9, 6 all. See, either you can write here. So I understood what is your problem. Either I can write here less than equals to n, or I can write it as n plus 1. Both mean same. Both are running for that only. Same thing you happens. Right? And write the position as 2 or 1 will write. 0, 1. Okay, both are same. Either you can write it as less than equal to n and plus 1. Both are same. Okay, that's all. Understood, everyone? Right? This is about your insertion. Either you can write here less than equals to n. Okay, clear, everyone? Understood, students? So okay, Siddharth, you were asking about selection sort, bubble sort and everything, right? So So what is this selection sort, bubble sort, and insertion sort? Only the technique is different. In bubble sort, we are going to compare with adjacent elements. In selection sort, what will I do is I will select one index and I will assume that that index is having the least element, and according to that, I'm going to sort. Insertion sort is very similar. How do you play your cards? So, ma'am, we should take the size of array more than the actual size, ma'am. See, plus one, only one, you are inserting only one element in the list, so you will print it only for one extra data. Previously, you used to print 0 to n, now you'll make it as n plus 1. That's all. Obviously, if you print only up to n, the last element is not printed. Okay, Siddharth. So, bubble sort, selection sort, insertion sort, what is the major difference is in bubble sort, we are going to compare with the adjacent elements. In selection sort, what will I assume is I will find the first minimum element. Later, I will swap. First, I'll find the minimum element in my list. Like, how do you find the minimum element of an array? Same way, I'll find the minimum element is present at which index. I will take that element and then I'm going to do this sorting technique. Now, when you talk about insertion sort, it is very similar to playing of your cards. I will pick first card, I will compare, and then I will. Now, how you did for inserting an array elements, right? The same way. Okay, that is only the difference. Anyhow, I'll share you the programs. You will understand more precisely how it is happening. So, bubble sort is working for adjacent elements. Selection sort will take the least element of your array, then it is going to swap. In insertion sort, what we do is we are going to apply the technique of playing of cards. Okay, everyone are clear with all the concepts which are discussed today in arrays? Any doubt with any of these concepts? So tomorrow you'll have the class strings, pointers, if time functions, otherwise on Saturday you'll have functions. Which time we will share you. Insertion sort, can you explain with a code please? Yes, sure, definitely. I'll write. Just give me 1 second time. I'll just write it off. Elements read, then this is not needed. So what will I do is I'll take one more loop, j, for I is equals to 1, I less than n, I plus plus. I write j is equals to I minus 1. Then I take a key element which is preserving my a of I element. Rid of all this, then I take key is equals to a of I. So I'll write a condition while j is moving, right? J pointer is greater than 0, and if key element is no, if a of j, right? If a of j is greater than key only, then what will I do? I will move a of, what should I do? A of j plus 1, I plus 1, I is 1, so 2. I write a of j is equals to a of j minus 1. If this loop is false, simply I'll write okay, j value is 0. K is equals to a of j. Is j greater than equal to 0? Yes. What do we have an element at this? Then I'll write a of j plus 1. So this is j plus 1. So a of j plus 1 is equals to a of j. A of j plus 1 is equals to whatever the element I have preserved in key.
happening on slideshow? What is happening? Okay, I'll show like this. Are you able to see the code? Siddharth, can you see the code? Okay, fine. So now you see how does insertion sort actually happens is, I need pen, right? So as I mentioned you, happened to this PPTs. Okay. So as I have mentioned you, your insertion sort is very similar to your playing of cards. Okay. For example, we have cards numbers like this 1, 3, okay, 10, 3, 2, 4. Let's assume you have the cards by numbers like this 10, 3, 2, 4. So insertion sort generally depends on number of comparisons and number of movements. First you do comparison, then you are going to do the movements, and then you are going to apply the technique of insertion. So you want to sort your list in ascending order. So first I'll pick the first card. That is I have 10 in my hand. So when I have 10, I have no comparisons and no movements. So 10 is fixed now. Now what will I do is I start comparing when I have the second card. Now my second card number is 3. What will I do? I'll compare 3 with 10 first. If the element 10 is greater than 3, first I'll move this 10 to the next location and then I will insert this 3 here. Now my new array will be what? 3 followed by 10. Now I got 2. Same thing. First I'll compare 2 with 10. I'll move 10 here. Again I'll compare 2 with 3. I'll move 3. After that I have no more comparisons. Then I will insert 2 here. So first you will compare, move, then only you are going to insert. So if you are having third element, you will do number of maximum comparisons are 2, number of movements will be 2. If you have 4 cards, number of comparisons will be 3 and number of movements also will be 3. So that is only the same thing we are doing here. Now let's take my list. 0, 1, 2, 3. We are not storing a new array, we are storing it in the same array. That is the reason. Yes, that's the reason we are calling it under internal sorting. This is your original array. I have the elements like this. Let's take, I have 10, 3, 2, and 20. This is my list now. Okay. So what I'm doing, I have read my elements. I'm taking one pointer I from this location. I said initial value, there is no need for me comparison. So I'm starting I from location 1. J will be before I always, because I should compare the element at 1 with 0. The element at 2 should be compared with 1 and 0. So J is moving backward, I will be moving in forward. So J will be at 0 now. Is J greater than 0? Because before 0 I don't have any comparison. So until if J is at 3, J should travel till 0. Before when it reaches to 0, it should not move for comparisons, because we don't have any data before 0 index. That is the reason I'm writing here J greater than 0. True. What is element in A of J we have? I'm taking element key where I preserve my original element of A of I. Key I'll store. You'll understand why I'm taking key. A of J is greater than 0. What do we have in A of J? 10. What is key? 3. Yes, 10 is greater than 3. So what should I do? I have to move first.
So what will I do? I write A of j plus 1 equal to A of j. Okay. What is A of j plus 1? Means this index 1 equal to A of j. What do you have in A of j? 10. So this 3 is replaced with 10 if you observe. That is the reason I am using key in order to store my previous value. Okay. Now j. Okay, I forgot to write here. J minus minus. Now j was 0. J becomes minus 1. J greater than 0. Condition is false because we don't have any elements at minus 1. Completed. So I'll come out of the while loop and I'll write A of j plus 1 equal to key. Minus 1 plus 1 becomes how much? 0. So A of 0, I'm writing with key. What do we have? 3. So this place is represented with 3. Okay, now what happens? Your new list is 3, 10, 2, 20. 0, 1, 2, 3. Okay, now for the second time. Now I plus plus. Now I starts from 2. Okay. Now I is at location 2. Definitely j will be at 1. What is key now? Key is the current element. That is key is 2. Okay. Now you see, is j greater than 0? What is j? J index is 1. Yes, 1 is greater than 0. What do we have at 1? 10. Is 10 greater than 2? Yes. So what will I do now? I will move first. Compare, move. So 10 is moved here. Here we have j minus minus. No, sorry. J will become 0. Is 0 greater than 0? Yes. What do we have in 0? 3. Am I right? So 3 is greater than 2. Correct. So what will I do? A of j plus 1 equals to A of j. So 3 came here. J becomes minus 1. Condition false. Minus 1 plus 1 became what now? 0. A of 0 equals to key. So this element is changed to 2 now. So this is your new list. Now you see, this is done. Now assume now again I plus plus. Now I became 3. Definitely your j is at location. This is I. Definitely your j is here now. Yes. What is key now? Key will be 20. A of I. Is j greater than 0? Yes. J is greater than 0. What is index of j? J index is 2. A of j. What do we have in second index? We have the element as 10. Is 10 greater than 20? No. So what will I do? I never execute this while loop. Simply I'll write A of j plus 1 equal to key. J plus 1 means A of 2 plus 1 is A of 3, which is equals to 2. So I get 20. This list remains same. Understood? Understood, Siddharth? Yes? Okay. Okay, fine. Thank you all. Have a nice day. I guess you have class at 12:30 again. Your drawing class. So any more doubts, you can ask me in the tomorrow's class. I will share you the time. Okay. Thank you all. Have a nice day.